Hello there, I'm Thomas Hatsen, German-American pilot flying the Boeing 787-900 tonight flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 1449, let's localize the landing around the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments displaying the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display that displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target airspeed selected from the autopilot and flight director system panel, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in 100,000 feet per minute, or the steepness of the trigonometric angles in degrees can climb and descend. We have also the altitude indicator with the artificial horizon with the pitch ladder in degrees and the bank angle in degrees. The Lszh localizer, the horizontal localizer, and vertical glide slope, so you can follow for alignment with the runway for an Lszh localizer landing. You have the magnetic North Pole heading for that, and you can follow the radio frequency transmitted from the runway threshold antennas, which transmits the frequency which is received from the Lszh, from the onboard aircraft Lszh localizer instrument landing system receivers. It displays the horizontal and vertical flight path we have to follow. The Lszh localizer crossbus. The flight director crossbus for manual guidance of the aircraft, and the autopilot crossbus for automatic guidance of the aircraft. We have also the flight mode announcer with the autopilot of the auto throttle, later and vertical navigation modes, and the angle of attack of the aircraft as it flies. You can see also the HSI with the integrated display of the flight plan, the horizontal situation indicator, also the navigation display. We have the magnetic heading and track, the magnetic North Pole and true North Pole magnetic varies depending on where we are in the world. We have the terrain map. You can see the terrain and weather reflections from the weather radar in a horizontal and vertical profile as they are depicted in the displays here. So you can see also the flight plan in a horizontal and vertical profile. You can see the magenta line here, the purple line. We have to follow and cross through some waypoints during the flight, as you're gonna see. So you can see the lines here. Also the primary flight display, the airspeed indicated, the barometric altitude, the target airspeed and the target altitude, the radio altitude, the pitch ladder. So we have all the information. You can see the horizontal and vertical profile in the navigation display. You can see the vertical profile we have to follow in glide using the flight management computer. Over here is the flight management computer, so I created a flight plan right now. The autopilot flight director system panel, the FIS panel, electronic flight instrument system. So I will show you all the systems one by one. The yoke, the flight control systems here, the thrust levers, the flaps and the slats, the speed brakes, the horizontal trim stabilizer, the thrust levers and the fuel control for the thrust levers. So I'll show you all the systems before going into takeoff. So now continue with the navigation display that displays the GPS position of the aircraft, the terrain, weather reflections from the weather radar, the terrain map with the airports. You can see that the airport we are located right now, the Zurich International Airport, the Lszh, and the runway we're gonna use for takeoff and for landing, the same runway, 14 in the Lszh airport, Zurich International Airport, Lszh, and the same Lszh localizer for takeoff and for landing. We're gonna have the same frequency tuned in the flight management computer, and the receivers are gonna give us the Lszh localizer guidance. So you can see also the airports, the name of the airports. We have the navigation aids. In the navigation display, we have the board stations, the ADFs, the NDBs, the waypoints which are horizontal, vertical navigation fixes the aircraft. We have to transverse through as it flies. So it will follow the purple line here. You can see the magenta line of the flight plan. The flight management computer we just created one. I will show you the process. So we have horizontal and vertical navigation fixes and altitude and airspeed constraints created by the flight management computer when I input the data. The takeoff gross weight, that includes the empty weight plus the passenger plus the cargo plus the fuel on board. Where the fuel is stored in the left and the right wing, in the center tank. Also the cargo where is stored in the compartments, and the passengers. The flight management computer is going to calculate automatically the center of gravity of the aircraft from takeoff, climb, cruise, descent, approach, and landing. Also, as it burns fuel, the center of gravity will be shifted during flight, so it's recalculated using the flight management computer automatically. The mean aerodynamic core position of the forward wings is also calculated for takeoff, like now is 23% of the Mach. The mean aerodynamic core of the forward wings is the position where we calculate the center of gravity of the aircraft for takeoff. Using the horizontal trim stabilizer, we're gonna trim the horizontal tail of the aircraft also for this purpose, like 4.25 degrees nose up. From takeoff, climb, cruises, and approach and landing, we're gonna be trimming either manually or automatically the horizontal tail position of the aircraft. So we can trim either manually or automatically. We have, as I told you, the maximum aerodynamic core position is the position where the maximum aerodynamic lift occurs in the forward wings. Is also the position where the stall, the airflow becomes detached in the top surface of the wings during flight. So it's gonna give us the stall. So we need to avoid the stall speed during the whole flight, and we can monitor here in the primary flight display. When we fly, it's gonna give us a yellow and red indication. It's gonna be the stall speed. The airspeed has to be always higher than the stall speed in flight. So this is the information. We use also the runway we use for takeoff, the Lszh International Airport runway 14, the runway length, the runway slope, the wind direction, speed, the barometric pressure, the density of the air, the temperature of the air, and also the runway conditions, if it is ice, dry or wet. It's gonna give us the takeoff speeds for these flaps we use. We're gonna use 15 degrees of flap, so it's gonna give us the V1, V rotate, and V2. So I'm gonna show you in the flight management computer in a couple of seconds all this information how created. I'm gonna have the takeoff, the seats, the southern instrument, the departures that include horizontal and vertical navigation fixes for the initial climb of the aircraft. Then we have the climb to the cruise level, like 35, 36, 37, 38, 39, 30,000 feet approximately. We have the cruise. We're gonna transverse through some waypoints during cruise, and we have the top of the descent. We're gonna initiate the descent of the aircraft from the cruise level back to the elevation of the airport for approach and landing. So we're gonna have the stars, the other terminal arrival waypoints and fixes for the terminal approach and landing, for the long final and short final. It's gonna help us align with the runway heading. Also, we're gonna use the Lszh localizer. The frequency is gonna tune. It's gonna give us the onboard receivers of the aircraft. They're going to receive the transmitted frequency from the runway threshold, from the antennas. The Lszh localizer, the instrument landing system of the airport, is going to align us with the horizontal and vertical glide slope, the horizontal localizer and the vertical glide slope. So we're going to use the magnetic North Pole heading for this flight, 136 degrees for the runway 14 in the Zurich International Airport, Lszh. So we're going to have a complete flight plan or flight path or route for this flight. Also, we can tune the Lszh localizer manually, automatically from the flight management computer, or manually using the radio management panel here, the communication and the navigation displays of the radio management panel. So I'm gonna show you the flight controls maybe in a couple of minutes. So we have the flight management computer here. I can show you. Here you can see I initialize the flight plan. As you can see, we have the index identity over here of the aircraft, 787-900, as you can see. The position over here, the performance. So we have the performance for this flight that includes the zero fuel weight plus the fuel on board. We have the gross weight for takeoff. Zero fuel weight is the passenger and the cargo on board, and the fuel give us a gross weight. The reserves 5%, the cruising altitude 25,300, the cost index 100, cruising fuel freeze temperature minus 37 degrees, in flight center of gravity of flight. So we have also the route here. I insert the origin, the departure, and the destination airport, the runway we're gonna use. So this will give us the flight plan. Insert thus the departures, select runway, and the seeds is gonna give us over here a complete flight plan. Then the arrivals over here, let's see its arrivals. ILS 14 and selected the stars, the negative and alpha and the Amiki. So we have the complete flight plan here created. From takeoff, also the airspeed, we can modify these values if we need. We can deselect something or add waypoint in flight. So we have Negra, Mativ, Amiki, Zui. This is the cruise level here to this flight level 22. So it's the airspeed here is 302 knots. Then the Mativ, Amiki, we start the descent, approach and landing over here. So we have the final fixes here, 5,000 feet, TRA, C114, 4,000 feet, also runway 14. So this is for the approach and landing. Runway 14, the elevation of the airport and the airspeed we need to have here as we approach. So you're gonna see the purple line. And, this is the first waypoint we have to cross through as we take off. The second one, this is the climb component over here. So we have also the flaps set for takeoff, center of gravity, trim, runway position, gross weight, give us the takeoff speed V1 128, we rotate 130, we take off 140 knots. This gross weight. So we have the takeoff reference, as I told, center of gravity to the and horizontal trim stabilizer. So we have other also views, VNav, alternate, navigation, radio fixes. So we're gonna look forward now to that. So we have here the flight plan created. I'm gonna show you over here. You can see the purple line from takeoff, the runway, takeoff, climb over here, cruise, we make a turn, approach and landing. You can see the plan also page, maybe better view. So we need to follow this purple line. In flight you can see the airports with the blue color over here. So this is the flight plan completed. The waypoints we have to fly through, the Zui, then the Nigra Amiki over here as with the return for descent, approach and landing. So you're gonna see also this part, you're gonna see the whole flight, some other modes you can see closer to the aircraft position here where we are located right now. Also the map. You can see also the vertical here profile as we climb. This is the vertical elevation of the aircraft right now, 1,430 feet, and we have to climb through this waypoint as we fly. If we look closer, you will see here also the runway position here from the GPS, the taxiway, and the terrain we have right in front of us and around. So if you look outside, you will see the runway here, same like in the GPS position. The GPS displays the runway over here, all the information we need for takeoff. Other aircraft also display. The terrain around you, you can see horizontal, how far away you look, with red, yellow and green, also with blue the sea. So we have also here the information: the airspeed indicated, the airspeed selected, barometric altitude, altitude selected, pitch ladder decrease, bank angle decrease, vertical rate of climb descent. This is the air data and the navigation information. So now I will show you the outside view of the aircraft. I will show you a little bit about Newton's physics and aeronautical and aerospace engineering, some principles we need to know about flying the aircraft. So you can see here is the wings of the aircraft. You can see the wings hold the weight of the aircraft as it flies. We have the thrust from the engines. The mean aerodynamic chord position is about 33% of the Mach, is where the maximum aerodynamic lift occurs. In the wings, approximately here, 23% of the mean aerodynamic chord. Where the stall also begins in flight, where we calculate the center of gravity for an airliner aircraft. Also we have the vertical axis, the center of gravity, the lateral axis from wingtip to wingtip, and the longitudinal axis from nose to tail, which transverses also the horizontal tail trim stabilizer, so we can trim the horizontal tail, and we can use also deflections using the flight controls, movement like this, as you're gonna see in a while. So you're gonna see also the flight controls movement, the deflections from the tail, the wings as we fly. So you can see the top surface, you can see the bottom surface of the wings is more flat, and also we have the curvature from the flaps extended. So as we take off and then as we fly, the airflow is moving slower below the wings using the Bernoulli theory of fluids. So we have higher pressure below with the wings, which pressurizes the wings up into the air with the aircraft weight. Also you can see the top surface of the wings is having higher curvature, so the airflow is moving much faster above the wings, which sucks the aircraft wings and weight in the air. So this is Newton's physics and Bernoulli theory of fluids we need for flying the aircraft. So I will show you also the flight controls now and set up the autopilot flight director system panel. So I will show you now the flight controls, how we use them. I use the flight controls of the Boeing 787-900. We have the yoke that controls the horizontal tail for climb and descent, deflecting the elevator up and down. We have the control wheel for bank rolls left and right using the ailerons and the spoilers. Also the rudder pedals for yawing turns. We can turn the rudder to the left or the right to yaw the aircraft in, when we have aerodynamic effective rudder in flight. And for nose steering in the ground, this interconnected with the tiller until some airspeed like a 70 knots. The tiller deflection decreases from like 76 degrees down to 7 degrees, and takeoff then to 0 degrees to like 70 knots airspeed. So we have also the toe brakes in the rudder pedal. So we have also the horizontal trim stabilizer. We can trim the horizontal tail of the aircraft during flight. It uses also the flaps handle that extends to retract the flaps and the slats. The speed brakes also, the thrust levers all connected to this side stick I use in the Lszh. It's the Lszh Extreme 3D for this flight. So you can see here I'm having the Lszh Extreme 3D. I can use it to deflect the yoke for climb and for descent. So this will move the horizontal tail section of the elevator, climb and descent like this. Also make turns like in the right. I can use only the turns right and left, or together everything. Also the rudder pedals, I can use only the rudder pedals if I wish to make the rudder turn, or the toe brakes. And we have the nose wheel steering, the tiller here, the thrust levers over here, so you can see. So we have the horizontal trim over here of the aircraft. we can trim the horizontal tail like this, down and up the other way. So this is trim down and trim. This is trim up this way, and this is trim down this way. So it will pitch up the horizontal tail of the aircraft. This way you can pitch the nose of the aircraft up or down in flight. So we have the stabilizer trim position here. So this will move outside, you will see, in flight or in the ground, doesn't matter. The horizontal tail we need in flight, up or down the whole surface. It will be trimmed in a position up or down in flight. So you can use also the elevator like this for climb descent without the trim. So I will show you also that horizontal tail function. So we have also the rudder trim here. So this is a horizontal trim stabilizer, the manual input. We have also the autopilot flight director system panel, has the automatic trim function when we connect the autopilot flight director system or the auto throttle, the automatic throttle. So we have also here the alternate pitch trim here. You can use the alternate trim down or trim up. This way trim up and this way trim down. So you can pitch up. We have the parking brakes also here, this handle. So I told you we have the horizontal trim stabilizer here, this switch. So you trim down the aircraft. Over here you see the horizontal trim stabilizer, here the position, and this will make the tail going up or down in flight, both tail surfaces, left and right. To balance the aircraft in flight, use the auto trim. Here you have a malfunction of the L2 and R2 hydraulic systems here. The auto trim function from the flight management computer and the fly-by-wire system, flight management system. So it's gonna have a malfunction. You'll have to come here and open this guarded switch, the red guarded switch. That exists in the Boeing 737, 747, 757, 767, 777, and Boeing 787. The stabilizer cutout switch from normal to cut off. So you use also after that, I believe, the alternate, and also you use the manual trim over here all the time is available, even if you disconnect the automatic trim function. So I will show you now the flight controls, how to use the side stick over here. So you will see the deflections of the side stick more closely, better view maybe. Better view, better also lighting. Maybe the lighting is not so good over here. So we need to fix only that. The lighting I think is okay. So we can use the horizontal tail like this, as you can see. We can climb and descend, make turns to the right, turns to the left, use the thrust levers also over here. So you can see the side stick deflection is proportional to the yoke deflection, and also the captain and the first officer, the yokes move together in flight, they're interconnected, unless we have a failure. They're not like the Airbus where you have side stick priority, also the rudder pedal. So we have coordinated flight, use all the flight controls like that. Also I will show you this view here. So we have deflection of the side stick, it deflects the yoke, as you can see. make turns, left and right like this, right and left turn. So hope you like my Boeing 787. We have also the thrust levers here. To better lighting. So we can climb and descend again as we fly the outside view, make turns, the rudder pedal. So climb like this. Descend. Can use the climb like this. Also make the turns here, left and right. So this is all the flight controls, I believe, for now. We need to know so much for the flight controls. You can see size of deflection proportional to the yoke. All flight controls, thrust levers here. You see the thrust levers over here increase when we move the thrust levers. You can see the commanded position and the axle. It takes a couple of seconds, or when you spool down to the idle. So I will show you also the thrust levers. So that was for the flight controls. Now we'll continue with the rest of the systems before making a complete flight from takeoff, climb, cruises and approach and landing. I will show you a little bit more of the cockpit, the autopilot flight director system panel, the panel with the engines indications, the ACAS system, the education controller system display, also the engines functions. So we have the General Electric engines, GNX engines installed in our Boeing 787-900 aircraft, one in the left wing, one in the right wing, for symmetrical thrust and redundancies. One contains a gearbox with the FADEX. The full authority is electronic control computers, dual channel redundancy, one channel phase, the other takes over, control monitors and displays all the engine data you see in the upper and the lower ACAS, or in the multifunction display of the aircraft, like the N1, which is the low speed slider sub, the low pressure compressor turbine of the turbofan to sensing, the exhaust gas temperature per engine, the N2, which is high speed slider sub, the high pressure compressor turbine of the turbofan turbocharged engine. The fuel flow per engine per hour, 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. We have also over here the pressurization from auto to manual. You will see what happens now. So we have the indications here of the engines. As you can see, so we have the N1, which is a low speed starter sub, low pressure compressor and turbine. Using the outflow valves here, it displays cabin altitude, rate of climb, descent here, the rate differential pressure. Right now 0, it will become like maximum 7.8 or 8.6 in flight, in the maximum flight level. The cabin altitude maybe will be like 8,000 feet when we fly at 40,000 feet. Differential pressure, PSI, landing altitude 1,417 feet, which is the elevation of the airport right now, using the automatic setting, and the outflow valves forward and out. This is for the cabin pressurization. You can see also a couple of warnings: cabin altitude auto, outflow valve after, now outflow valve forward. So the TCAS system also is off. So I'll show you. So we have the display of the engines indication, the N1, the exhaust gas temperature, the N2, as I told you. The FADEX control and monitor display all these indications. the fuel flow to the engines, fuel metering unit, the cabin pressurization system receives admitted air from the 5th and 9th stage of the engines, outflow valves of the high pressure compressor and low pressure compressor turbines. So compressors, we have also the bleeder from the front fan of the turbofan budget engine, the bypasser stage. So we have a bleeder for the hydraulic fluid tanks pressurization, for the wing and engine anti-ice, air conditioning, ventilation, and cabin pressurization system, and also for the oxygen regulation in flight, because we use pressurizer admitted from the engine. So you see the hydraulic systems here, all the flight controls. I just saw you here. The elevator, the horizontal tail, vertical tail, the rudder pedals, nose with steering, flaps and slots, speed brakes, thrust reversers for the engine, landing gear extender retract, auto brake, parking brake, nozzle steering here. All these things, the yoke of the Boeing. We need hydraulic fluid pressurization for these flight controls here, so it's pressurized with the engine function with pressurizer, and also some kind of primary in demand. We have left and right electric and engine driven hydraulic. We have some hydraulic pumps here, electric and engine driven pumps. So we have also hydraulics, cabin pressurization, wing and engine ADIs, air conditioning and ventilation, all these systems, oxygen regulation in flight. So the FAREX controls also engine start, engine shut down, the pressure inside the engine. If we have an overpressure and under pressure, it will open and close the outflow valves in the higher low position to increase or decrease the pressure inside the engine. We have also the as we fly the aircraft into higher altitudes from the sea level, all the way up to like 20, 30 or 40,000 feet above the sea, like 9,000, 10,000, 11,000, 12,000 meters above the sea level. As we fly higher, the air pressure, the oxygen level and the density become less than half that of the sea level. Also the airspeed of the aircraft becomes like 2 or 3 times faster than that of the sea level. So we have a higher intake of airflow from the front fan stage for compression into the engine, and fuel mixture request every second is being adjusted automatically from the FAREX, instead of doing manually like we're doing the turboprop in the small trainer aircraft with propeller engine, since this is a turbojet with jet engines. So we have automatic fuel mixture. Also as we descend, vice versa, we need to adjust again. All is done automatically, all the fuel mixture. So we have also the FAREX control, the fuel temperature, the fuel meter, fuel heat exchange sensors, and the temperature of the fuel. So we need to recirculate when we fly the fuel from the wing tanks and the center tank to the engines for duct heat from the engine components, and cool down the engine components, and also heat up the fuel and the oil of the aircraft, because we're gonna freeze the fuel to like minus 37 degrees, because when we fly maximum altitude like 20, 30 or 40,000 feet above the sea level, we have temperatures like minus 30, minus 40, minus 50, minus 60 degrees below zero. So we'll freeze the fuel and the oil. Also we have wing and engine on the ice over here to avoid freezing these components over here. So I will show you also so this is it's a good thing to have the FAREX installed into your aircraft. I will show you the indications now from the engines over here in the multifunction display. You'll see we have the N1, which is the low speed starter shaft low pressure compressor turbine of the turbofan turbine. This is the left engine versus the right engine. You can see in the idle position 19.8%, maximum takeoff is going to be 100.4 with green limit, yellow and red never exceed. So exhaust gas temperature per engine left and right, PN2, which is the high speed starter and start the high pressure compressor and turbine of the turbofan, puts the engine, the left and the right fuel flow principle per 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, vibration of the N2 stage of the engine. Over here, gross weight with the fuel on board, total fuel on board, the fuel temperature right now, saturated air temperature. We have the pressure here of the outside atmosphere right now, 29.92 inches of mercury. You can see displayed with the radio 200. So we have the pressure of the air set it here in the FS panel, the altitude barometric set inches and the minimums and the range of the maps. So we have also over here the air data control computer. So this we have the heading reference over here, the IRSNS reference system, heading reference, magnetic north pole, true north pole, geographic north pole, laser gyroscopes for alignment of the aircraft also in the ground. We have laser gyroscopes for gyroscopic acceleration and deceleration. In flight you see the altitude indicators display. We have the airspeed, the pitot static, pitot tubes, pitot static, pitot dynamic for the airspeed and the altitude, radio altitude, angle of attack of the aircraft as it flies. So all the air data you see here, and the GPS, 3 GPS receivers, angle of attack of the aircraft. All these are controlled from the air data computer here. So we have over here the airspeed set right now from the autopilot flight director system panel. So we're gonna set autopilot flight director system panel over here. So we have landing altitude here, extend and retract, alternate gear also, you can see alternate, auto brake here, reject takeoff, for landing also settings, a couple of settings. We have, as I told you, the flaps position here. You can see the flaps retract and extend, left and right engine thrust levers, fuel control to the left and right engine, fuel flow, run or cut off. This switch, when we turn off, we can turn off the engine, fuel, engine fire switch left and right, pull out and switch, transporter, rudder trim. So this is a radio and communication panel. So we have also, as I told, horizontal trim, speed brakes like this, extend and retract, extend like this, this position. We have the thrust reverse here. So we move this up, it will display the thrust reverse is being deployed right now. So you see with the green the reverse, and the thrust from the engines increases. So we disarm the thrust reverse like this. We have also the auto throttle. Here is the auto throttle disconnect switch. Disconnect the auto throttle in flight, takeoff, go around. So this is left and right engine, thrust reverse. So we have the autopilot flight director system panel here. I will show you a couple of things. Autopilot engage and disengage like this switch. You can see auto throttle left and right. So this is the auto throttle, flight director, LNAV and VNAV here. So this is the airspeed guidance of the aircraft with the autopilot engage and disengage, the flight director. If I disarm the flight director, turn it off, you will see the LNAV and VNAV disappear. You cannot rearm unless we have the flight director on. So we change the airspeed like this. When I use an airspeed for flying the aircraft, for initial climb, autopilot here engage, disengage, flight level, change, climb continues, auto throttle, VNAV and the LNAV, indicated airspeed or Mach. We have also the bank angle limit as we fly. The heading, we're gonna use the magnetic north pole heading, 136 degrees. The bank angle in flight. We have the altitude here. We set the initial climb like 25,000. 300 I have set. You can set also hundreds. The whole vertical speed here, so you'll see the descent like this. This way we can descend the aircraft. You will see the minus sign. The other way we can climb. We can set to zeros and also the climb level. So we have also the VOR localizer and the auto land function of the Boeing 787. So now the autopilot flight director system panel will display here in the head-up display all the information, same like in the primary flight display. You see the airspeed and the altitude change to the target airspeed, target altitude with purple. Airspeed indicated, barometric altitude, the vertical rate of climb descent of the aircraft 10,000 feet per minute, the pitch ladder 2.5, 5, 7.5, 10 degrees, 12.5, 15, 17.5, 20 for pitch up or pitch down. So you have to pay attention to that and do that because maybe you have a positive pitch attitude in flight, but the aircraft might be falling. You will see this needle to tell you whether it climb or descend, and also the airspeed, radio, altitude, the intercept here, the flight long. So we have all the navigation display we need. We'll make an engine start demonstration. Also now the overhead panel, the electrical, I will need to start the APU to make an engine start demonstration. The APU is going to provide us with electric power, alternate current, 120 to 200 volts, 400 Hz frequency, and also 120,000 kilowatts, and also maybe less than that because we have the IDGs for that from the engines, 130,000 kilowatts probably. Left and right engine, the APU. Over here we're gonna start it like this. It's gonna give us pressurizer. We need pressurizer for starting the engine starters. When we're gonna shut down the engine, we have the battery, APU generator, controllers, 120 to 200 volts, 400 Hz frequency, external power. Also we have the primary flight control computers, also the overhead panel in the auto position, air data computer here, heading reference, IRS, flight control surfaces, FT door here, towing, passenger oxygen, window heat here, rammer turbine, hydraulic system over here. If we turn off like this, it will display something. You will see the fault, the primary, the engine drive, and the electric. So we'll leave back to on, then to auto. The hydraulic pumps. We have also the wing and engine on the ice here, as you can see, on or auto. So this is also the lighting system and the windshield wipers. So electric, hydraulic, fire extinguishers for the APU and the cargo. Some other systems here. The electronic engine control for the engine, left and right, normal and alternate mode. Auto start also. You can see the engine control, fuel jettison. You can dump some fuel in flight using that. You are selecting the nozzles also. Fuel, left and right wing, fuel tank, fuel booster pumps, center tank, crossfeed valve. We turn it on. We can feed either engine with other pump or either tank. So we turn on all fuel booster pumps. We have the balance also here. So we don't need the crossfeed right now. We have also the pressurizer section with the air conditioning, ventilation, oxygen regulation inside. The aircraft climb descent here, the outflow valves in the manual. Select the auto. We have the automatic pressurization. So this is all the overhead panel we need to know right now. I will show you a little bit now. You will see the displays here in the digital format. All the systems I show you in the overhead panel. So we have the hydraulics, quantity, pressure, PSI, rotation per minute of the APU, oil pressure, oil temperature, oil quantity, oxygen, and liquid cooling. So this is the status display. Here we have some warnings. The electric using the overhead panel. You see left and right IDG, the great drive generator. The APU is running. The load set and the battery volts, 31 volts, an APU battery. So we have hydraulics, where the hydraulic fluid goes, which systems use it. Left engine, right engine, electric, shut-off valves, quantity here, pressure 5000, 100 psi, and the quantity of hydraulic fluid, fuel, left and right wing. So you see whatever is in the overhead panel. I show you here all the diagrams of the system. You see them now, as I told you, digital format. Display, you see now fuel left and right wing, how much fuel you have, 11.2 and 11.2 thousand, center 11.2, total 33.5, low and high pressure fuel valves left and right engine, open feed both engines, APU is fed from the left wing using the DC motor, the crossfeed valve is off, but if we turn it on, it can feed either engine with other panel or either tank. Also you can see the minimum fuel temperature here, minus 37 degrees, below which the fuel will freeze in flight. We have the air conditioning and pressurizer from the engines or the APU. The doors are closed, the cabin can be pressurized, the gear, temperature of the brakes and pressure of the tires of the nose will also, flight controls here. Last thing we need to know over here as we move flight controls, the tail horizontal trim stabilizer. So this works correctly like this. This function is correct. So we have FS display also, maintenance, circuit breakers, and the last thing, the checklist, normal menu, what to do before flight, after landing. So use the navigation display again. We need to start the engines very quickly now. So I'm gonna make an engine start demonstration. Shut down both engines. So I turn off like this the fuel control. You will see the fuel indications, the engines indication are slowing down. I'm gonna have some warnings. You can see the N2 is decreasing. You can hear also the roar from the engines. So we need to come here in the overhead panel and turn on the auto start system. Both engines the auto start on. So you see the yellow indications in the overhead panel. So we're gonna have pressurizer now coming from the engines. The N2 increases above 20%. We can let we have only pressurizer now to the engines. So above 20%, we can let the fuel flow here. As you see, fuel control to the on position. So we have the auto start on, kicking in. 31 and 30%. You're gonna see all the messages, the warnings are going off in a couple of seconds. So we have the auto start ready. Is increasing, so you'll see all the yellow indications. 55%. The engines are stabilized, and we have running both with green letters. Both engines running. So we're gonna go now for the flight very quickly. So we advance the flaps for takeoff like this, the thrust levers, parking brakes off. We take the clearance from the air traffic control. So the runway is open for us for taxiing to the runway. We can use it for takeoff. Align with the center line like this, using the tiller, as you can see. So advance the thrust levers, and we take off. Maximum takeoff. So we have 90 knots, aligned with the rudder pedals, left rudder, a little bit. 130 V1, we rotate. So rotate slightly. As you can see, keep climbing. Speeds up a little bit. Positive rate of climb. So we have landing gear up like this. So we keep pitching up the aircraft. You can see I can use this to control the aircraft flight path. So we need to follow over here the flight plan. The airspeed, we are 1,700 now. The radio altitude 1,900, 2,000 feet above the ground, about 3,700 above the sea, 2,200 above the ground, 4,000 feet above the sea. Difference, we climb with 4,000 feet per minute. The pitch altitude 12.5 degrees right here. The level of the wings 230 knots. The airspeed. So we see a couple more things here. The indications from the engines. We have the terrain around you, and below you can see the terrain, how far above the terrain we are, the aircraft. If we look also further away, a couple of you will see the red here, the yellow and the green indication of the terrain. So we have the flight plan here. We need to follow. So this is also the outside view as we're climbing. We have the Zurich here, beautiful view of the Switzerland. So we need to start now the turn. We start the turn to follow the flight plan like this and increase the airspeed, perhaps some less flaps. We need gonna have higher airspeed, and we need 15 more minutes to come back to the airport before the video will end. So we cross these clouds with no problem. We can see the altitude here and the terrain. We have a problem. Navigation display, even we have zero visibility. So keep following. Here the flight plan we're gonna follow. I'm gonna increase also the airspeed like this. I'm gonna have also the flight plan displayed here. So now we need to start turning to follow the lines here of the flight plan as we climb. So maybe you can see the stall speed in a couple of minutes because we climb higher now, at a higher rate maybe. Need to come with a lower airspeed incline. Maybe we need to increase the airspeed like this of the aircraft, accelerate. So let's see a little bit the outside view over here of the aircraft. The Switzerland, very beautiful view. The Swiss Alps, the lakes. We have the lake. We have to fly through the Germany, this side with the Bayern Munich and the France, and also the galactic view over here of the Boeing 787. So this is the view. Nice view over here. We need to make a turn now over here. So we have 12 more minutes for this flight. I'm gonna start the turn in a couple of minutes. The turn for going back to the airport. $19,000 feet over here. $20,000 feet. Need to follow this flight line here, as you can see. You can see the airspeed 243 knots, the Mach speed right now 22,000. Gonna be flying a bit higher than the normal. We have to, so we have the lake view also, beautiful lake here in the Switzerland, the Bayern Munich here, the Germany, my homeland, and the France, and the Italy the other way, the Switzerland. So we have also the galaxy here, beautiful galactic view of the Boeing 787. So perhaps we have the cruise altitude now reached it, 84,000. We need to start the turn now. Over here, I'm gonna turn back to the airport. Use some right rudder also as we turn, and the control wheel. And we need like 10 more minutes to go back to the airport like this. A little bit less engine power. So you see how we turn. We're gonna change over here. Here we are. Beautiful turn, overflying the Germany, the Bayern Munich, the lake, the Switzerland, the France on this side. So we have the Swiss Alps again. A beautiful view. So we have approximately 9 more minutes for the flight to arrive to the airport. So we need so we are aligned now with the flight plan. Keep flying over here manually, as you can see. So here we are. We have also chemtrails, as you can see. The contrails, the chemtrails from the aircraft, very beautiful. The France on this side, the galaxy also view. So we have a beautiful view here. And we need 8 more minutes to go back to the airport, so we may start now the descent. So we use idle thrust like this. Idle thrust. And pitch down the airplane. Keep flying manually. And we have 7 more minutes for this flight. So we keep having the chemtrails, beautiful chemtrails here, created from the airplane, as you can see. The lake, the Germany, Bayern Munich, the France, on this side, the beautiful galactic view. And we have 6 more minutes left for this flight. We need to pitch down the aircraft. We have 3 minutes to descend and 3 minutes to approach before the video will end. So you can see the airport here where it's located. Maybe use a little bit more idle thrust now. We'll start the turn, I believe. We're having a good approach now. We're gonna have 5 more minutes for the approach. I believe we're gonna make it before the video will end. So we have a nice view of the cockpit inside. Let's see the head-up display here. So we need to approach, and we have 5 more minutes approximately for the landing part. Let's see, we take the turn now. For the approach, we need to follow the flight plan. Also use left rudder. You can use that for slowing down a little bit. So you can see we are approaching here. So we are almost aligned with the runway, and we have 4 more minutes to approach the land. We're gonna use also some flaps now, some landing gear, and advance the thrust levers as we are approaching. Also we have the outside view now. We're gonna have a very nice view here as we are approaching from the aircraft. So you're gonna have to use more flaps like this for the approach. You can see also the Lszh localizer here. We have the intercept, the localizer, the glide slope, and also the terrain around you and below you. Here's the information. So we need to align. We have some side wind here, align with the runway. Here's some flight controls, some left rudders, some right now, to make proper alignment before touchdown. I'm gonna use also full flaps maybe. So we're gonna need use less thrust now. We need to align with the runway, all flight controls. We have some side wind. Also use the flare now, flare with the align with the runway, and also flare the aircraft before touchdown. So we have the flare, beautiful flare, touchdown, beautiful touchdown, parking brakes, thrust reverse, idle thrust here, and thrust reverse, as you can see. So we're slowing down, align a little bit left rudder, a little bit, not over control, a little bit right, maintain the center line as we're slowing down. So you see we are slowing down the aircraft right now, maintaining the center line. So we have 40 knots now, 30, and we landed. We made a very beautiful landing here, as you can see. So you can see the aircraft here. The nose wheel is perfectly safe. There is no breakage. Also the nose and the landing gear behind it. You can see all the tires and the wheels. There is no breakage from the landing. You can see all the parts are perfectly safe. Also, you can see the aircraft is starting up the way it should be. You can see the nose wheel here, perfectly safe. All the parts of the nose wheel here and the tires. So we can do another flight with this aircraft. So we can also disarm the thrust reverse like this. You will see the thrust reverses. So that was Thomas Hatches, the German-made Alpha flying the Boeing 787-900. Thank you for staying with me tonight again. One more flight. I'll see you next time. Bye bye. Bye.